Assalamu alaikum. So today we're going to finish the last part of this Calculus 1 General review. So let's start with the first question. Here they ask me to find out the integral between minus 4 to 4 of sine to the power 5x dx. So when you have this type of integral and the boundary are opposite, check what type of function you have, either even or odd function. So if it's odd function, if f, so if I have the integral between minus a f of x dx equal, I have two choices. I can get 0 if f is odd, or I will have twice the integral from 0 to a, that means it's almost like half of the integral of f of x dx if f is even. So what I need to do first, if I have that type of question, I check my function here. My function here is f of x equal sine or 5x. So I check if it's even or odd. So for odd, so I need to make sure that f of minus x equal minus f of x. For even, I have to make sure that f of minus x is equal to f of x. So I check f of minus x. Either I will get this one or that one or neither. So if I have f of minus x, it's going to be sine 5 of minus x, which is the same thing as sine of minus x to the power 5. And we know that sine is odd. Sine of minus x is minus sine x, so this will become minus sine x to the power 5. So I distribute the 5 here, so it's going to be minus 1 5 sine 5x, and we know this is odd, so it's going to be minus, so it's going to be minus sine 5x, which is, you see, this is my function, so it's going to be minus f of x. So therefore this is odd function. So if it's odd function, I just apply the first rule, which is 0. So this is equal to 0, so I don't have to waste my time doing it. So if you know it, so it's taking only 1 second to do it. You notice that the boundary are opposite, and check if this is odd, then you just state is 0. Okay, so let's see if you didn't notice about odd or even function. So what to do with that type of question? Alright, so when you have that type of question and you didn't notice if it's odd or even function, so what you do, always split it into two equal integer function. Two equal integer function. That means the midpoint between minus 4 and 4 is 0. So this, it's become minus 4 0 of sine 5x dx plus from 0 to 4 sine 5x dx. Then try to make this boundary look like the same thing as the one by using substitution. So here we choose x equal minus t. So the boundary here, if it's minus 4, t will become 4. If x equal minus 4, t will become 4. If x equals 0, t will become 0. So when I have minus 4 here equal minus t, that means t will be 4. If I have 0 equal minus t, that means t will be 0. So now when I do substitution, what I do here, I change the boundary, so this will become 4 0 because minus 4 become 4. Don't switch the order, keep it at the same place and just substitute it. Keep the boundary at the same place and substitute it. Then here x is minus t, so it becomes sine 5 minus t, and dx, so when we have dx here, it's going to be minus dt. So this will be minus dt. Minus dt. And we just showed that minus can be pulled out from the sign because sine is odd function. So I can pull out this minus out, so it's going to be minus, it's going to be 4, not minus 4, it's from 4 to 0 of minus sine 5 of t minus dt. and minus minus become positive, so this will cancel out, so it's become 40 sine 5t dt. Now I need to switch the boundary, and we know that if I have a b f of x dx is equal to minus ba f of x dx. If I switch the boundary, I pull out a minus sign out, so this will become minus the integral from 0 to 4 sine 5t dt. You can substitute it back, you can do substitution again, so I can put t is my x. I do another substitution. I don't have to do it back on the same thing here, so I just put t equal x in order for me to have the same variable. Then this will become 0 4 sine, don't forget the minus, 5x dx, because this will be dt will be dx. Now look, I have this and I have this, so my expression will become minus the integral from 0 to 4 sine 5x dx plus the integral from 0 to 4 sine 5x dx. As you see, the same quantity but opposite sign, of course, equals 0. So if you didn't notice this, use that idea, it will help you get the right answer. But please try to keep in mind those property of even and odd function, the integral of even function and the integral of odd function. It's very helpful. Like as you see here, if you know it, it takes you only 1 second just to put 0, and that's it, and you move on. So now let's do the next question. Next question is it has absolute value, so we cannot integrate with absolute value. So what we do here, we pull out the absolute value out. So how can I do that? So I need to check the sign of the function. So we're going to use this property, absolute value of x is equal to x if x is positive, and is equal to minus x if x is negative. So I need to check when x minus 2 is positive and when x minus 2 is negative. So to check this, what we do, we need to find out the 0. X minus 2 is equal to 0. This means x equal to 2. So we know that, you see, at 2 here, x minus 2 is equal to 0. And we know on the right side of 0 is positive and the left side of 0 is negative. That means anything less than 2, this is negative. Anything greater than 2, this is positive. So that means here x minus 2 is greater than 0 and x minus 2 is less than 0, and at 2 is equal to 0. So now I'm going to apply this property here. So my x here is x minus 2. It's like I'm doing here. Let me show it to you in a different way. It's like I'm having a box, and I need to check the sign of that box. If I have a box, this box is equal to itself if it's positive. It's equal to minus itself if it's negative. So my box here is x minus 2. So now I need to split this into two intervals. So I have the integral from 0 to 4 absolute value of x minus 2 dx is equal to the integral from 0 to 2, where the sign change of this expression. So the sign change of the expression at 2. So I'm going to do it from 0 to 2. If you got another number, you use that number. Check where it's equal 0, because at 0 where the sign change. So here it's become absolute value x minus 2 dx plus 2 to 4 absolute value x minus 2 dx. Now I know that x minus 2 less between 0 and 2 is negative. You see, between the interval 0 and 2, this x minus 2 is negative. That means I will end up having minus x minus 2. So this will become 0, 2 minus x minus 2 dx plus, and between 2 and 4, so between 2 and 4 here, so we know it's positive, so it's going to stay the same. So it's going to be x minus 2 dx. So I distribute here and I integrate. So I will have between 0 and 2 minus x plus 2 dx plus the integral from 2 to 4 of x minus 2 dx. And this is very simple integral. So here I will end up having minus x squared over 2 plus 2x from 0 to 2 plus the integral of x squared over 2 minus 2x from 2 to 4, and I substitute. So here I will end up having minus 4 over 2 plus 4. The 0, if I plug in 0 here, is going to be just 0, so I don't need to put minus 0, plus, and here I will have 4 squared, which is 16 over 2 minus 8 minus, and I will have here the second one is going to be 4 over 2 minus 4. So here is minus 2 plus 4, which is going to give me 2, and here is going to be 16 over 2 is 8, 8 minus 8 is 0, so this is cancelled out, and here I will have 2 minus 4 is minus 2, and minus become 2, so it's going to be plus 2, so here will be 4. So the answer here is 4. Next question. So here we have the integral from 1 to e ln of x to the power 4 over x. So when you have this type of question, you can check, okay, which one I substitute with which. So when you have ln, check the derivative of ln if it's going to give you 1 over x, because this is the same thing as the integral from 1 to e ln of x to the 4 times 1 over x dx. And we know already that d of ln of x is dx over x. We already know, because this is what you learn in school. So d ln of x is dx over x, and this is what we have here is 1 time 1 over x dx is dx over x, so that's mean here my u will be ln, so I'm gonna substitute u by ln of x. So here, which means the boundary is gonna be from 0 to 1, so when we have x is e, so u will be 1, and when we have x equal 1, u will be 0, so my boundary will be from 0 to 1, and we have u to the 4 du. And this is very easy to integrate, so it's going to be u to the 5 over 5, and going from 0 to 1, so of course it's going to be 1 over 5 plus minus 0, which is just 1 over 5. Is that clear? Alright, for next one here, so we have the integral from, but there is no integral, this is undefined integral, so it's going to be x square root of x minus 4. When we have this type of question, always you see the power are the same, so here 1, this is 1, so take the whole thing is my u. So take the whole thing is your u. So here I will have u is square root of x minus 4. So which means u square is x minus 4. Then 2u du will be my dx. And here, look at this. If I move the 4 here, I will get my x. X is u square plus 4. So as you see here, I got my x, I have my u, and I have my dx. So what I do here, so I will substitute, so x square root of x minus 4 dx will be, so what is my x is u square plus 4, so I'm going to substitute it. What is square root of x minus 4 is u. What is dx? 2u du. 2u du. That's all. Then you multiply this, you distribute and integrate. So it's going to be u square plus 4 times 2u squared du, and you distribute it, so it's going to be 2u to the 4 plus 8u squared du, and you integrate, so here is going to be 2u 5 over 5 plus u 8u 3 over 3, of course, plus c. Now I substitute back my u, so here will be 2 square root of x minus 4 our 5 over 5 plus 8 square root of x minus 4 cube over 3 plus c, and you're done. For that one, so when you have this type of function, check the derivative of the power function. Here the function here is sine. I will check the derivative. If it gives me the top one, then I will do substitution right away. So the derivative of sine is cosine. So what I do here, I'm going to use my u. U is sine of x. So du is cosine of x dx. As you see here, this is my du. So it's going to be du over. So here, if I substitute, so I get the same thing as, look, 1 over sine 9x cosine of x dx. So as you see here, this is my du, and this is u to the power 9. So this is the same thing as 1 over u to the 9 du, which is the same thing as u to the minus 9 du. And we integrate this, so this is minus 1 over 8 u to the minus 8 plus c, and substitute u by sine, so it's going to be minus 1 over 8 sine 8x plus c, and you're done. Here again, when you have this very simple integral, that means you have x and you have e to the x or something like that, always take the whole statement of e and make it as u. So take u is e to the x 4. So what's going to be my du? Du will be x to the 4 prime times e to the x 4 dx. So here is going to be 4x cubed e to the x 4 dx. As you see here, I have this expression here. So what I do, I divide u. So du, I divide both sides by 4. So I got my du over 4 is equal to x cubed e to the x 4 dx. So you see the whole expression is equal just du over 4. So here I will end up having what? X cubed e to the x 4 dx is equal to du over 4, which is the same thing as the integral of I put 1 over 4 outside du, so this is the same thing as 1 over 4 u plus c. And what is my u? Is this expression, so my final answer will be 1 over 4 e to the x 4 plus c. I hope it's clear. Next question here. For that one, don't substitute, don't do anything. This is very simple. Just FOIL it. But when you FOIL it, please, 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 don't distribute the exponent. I see this a lot. So please FOIL. FOIL. We don't just mean FOIL. FOIL. First out in last. So this is square, so I will have 2x squared plus 2 squared, the same thing as 2x squared plus 2 times 2x squared plus 2. First out in and last. See, this is what I'm expecting from you guys. Alright, so here it's become what? It's become 4x4, yes, plus if I FOIL at the end, so I will end up having 4x4 plus 8x squared plus 4. So this is the polynomial I will integrate. So here it's very simple, so it's going to be 4x5 over 5 plus 8x cubed over 3 plus 4x plus c. And say it again, please, when you have this type and you have power like this, don't distribute. Do not distribute the exponent. FOIL, especially if you have addition, subtraction. If it's multiplication, yes, you can distribute. Multiplication, division, yes. But when you have addition here or subtraction, please, 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 for you. All right, here for that type of question, it's given to you already by in your lesson. It's always given to you the integral of cosecant square of x is cotangent, and you know the derivative of cotangent is minus cosecant square. So we know that the derivative of cotangent is minus cosecant square. So that means the antiderivative of cosecant square is going to be minus cotangent. So this you should know already from the derivative that this it will give you cotangent x plus c. So suppose I didn't know this. So what I need to do in that case, you need to know very well your trig. If you don't know that the antiderivative of cosecant square is minus cotangent, so you should know very well your trig and the derivative, because in order for you to pull out the answer like that, you need to apply the trig and the derivative. So for example, well, let me do it here for you. So here we know that the cosecant square of x is 1 over sine square of x, and we know that sine square of x is what 1 is what is sine square x plus cosine square x over sine square x. So, and what is sine square is sine times sine, so they're going to be sine x times sine x plus cosine x times cosine x over sine square x. And here I'm going to use the idea of the quotient. If I have f over g prime is f prime g minus f g prime over g square. You see, my g here is sine. That means here I have g. That means here I have a derivative of g here. This is g prime, which is cosine. And that means this one should be the derivative of sine, of cosine, which is minus sine. But here I don't have the minus, so I'm going to put minus here. So here I will have what? I will have minus cosine of x prime times sine of x plus, you see here I can pull out this minus inside here, so it's going to be a minus here. I need to have a minus here, minus cosine x times sine prime x over sine square. So I'm going to pull out this minus inside to have my function f is minus cosine x, not cosine x. So here it's going to be a minus cosine x. So when I integrate, always the minus stays as it is. Then as you see here, this is my f prime g minus f g prime. So f is my minus cosine, so it's the same thing as minus cosine of x over sine of x prime, which is minus cotangent of x prime. So this is this prime, and this is what you're learning on the derivative. Now to integrate, just to cancel the, you see if I integrate here and integrate here, the integral derivative cancel out, and I add my c. Is that clear? Alright, but normally you should know this from the derivative. That means know your trig and know your derivative of the trig. It's very helpful. Sometimes that type of question will take you only like few seconds and you're done. So you don't have to waste your time doing this stuff because you forgot about this property. Alright, so here let R be the region bounded by the curve y equals square root of cosine x, y equals 0. So my y equals 0 is this, which is here. Oh, this is x equals 0, sorry. Vertical is x equals 0, my y equals 0 is this is y equals 0, which is the x-axis. Alright, this is x-axis, this mean x-axis, this mean y-axis. And here we have x equal pi over 2, so it's going to be the vertical line here, which is at this point here. So this is the boundary. So I need to get this area here. So I need to get the volume here, so not the area. Find the volume of the solid obtained by revolving the region about the x-axis. So if I do, if I revolve the region about the x-axis, normally I should get a graph similar as this one. It's not exact, but that's the idea. Now I need to do my cross section, so I'm gonna use some. There we go. This is my cross section. So I'm gonna create a very small rectangle, cylinder. There we go. There we go. So let me get this. This you can see the idea. There we go. This is my cross section. Alright, so as you see here, this is my cross section. You see, this is my dx, which is the height. Now, what is my radius? My radius is this from the center here, so which is my y. So this is my radius, which is y. And if I have the height and I have the radius, I can get the volume. So we know that the volume of a cylinder, the volume, and this is the partial volume, so we name it dV. So it's going to be what is the height times the area of the disk, which is pi r square. And what is my r is y, so it's going to be y square. So this is going to be my dV, is the area of the disk times the height. Now because I'm looking for the whole portion here, so I will integrate from 0 to pi over 2 because I have the x. You can see we have y here, so because I can substitute y by cosine. So here the same thing here as 0 to pi over 2 of pi square root of cosine of x. I substitute y by square root of cosine of x dx. So here the same thing from 0 to pi over 2 pi cosine of x dx. So I pull out the pi out, so it's going to be pi square root integral from 0 to pi over 2 of cosine of x dx. So what is the antiderivative of cosine? Is sine. So like, let me remind you this again. So this is the circle. This is what I use most of the time, even when I was in college and in school. So I use this idea. So this is sine, cosine, negative sine, negative cosine. Derivative of sine is cosine. This is the derivative direction, and the opposite will be integral. So derivative of cosine, negative sine, and so on. The antiderivative, you just do the opposite direction. So antiderivative. So the circle will get you everything. This is why try to learn the trig on circle, and you can understand most of the thing on it. Alright, so here I will have pi. The antiderivative of cosine is sine, so it's going to be sine x from 0 to pi over 2. Sine of 0 is 0, so it's going to be pi times 1 minus 0, which is going to be just pi. So I hope this is clear. So let's do next question. So here R is the region bounded by the curve y. This is a parabola, y equal 4. So let me graph it for you here, because this should be graphed. So I have my coordinates. So because x squared plus 4 is positive polynomial, because the discriminant here is going to be negative, so that means it's above the x-axis. So I'm going to assume that this is 1, 2, 3, 4. So this is my, when x equals 0 is 4. And let me give you a rough graph of this, how it look like. There we go. It's not that perfect, but just accept it as it is. It's okay. Alright, so this is going to be my x squared plus 4, and what they want I have a line y equal 4, so it's going to be horizontal line y equal 4. which is here. This is y equal 4, x equals 0, which is here, and x equals 2. So let us assume 2, this is 1, so it's going to give me 5. 2 is going to give me 8, so 8 will be somewhere here. Alright, so this will be my 2. So this is y equal 4, this is x equal 0, and this is x equal 2. So what they want the area of this region, or the volume. Okay, here they use the volume. Alright, here find the volume of the solid obtained by revolving the region about the line x equal 4. So here we're gonna do another line. So it's gonna be, this is 3, 4. So it's gonna be, this is my line equal 4. So I'm gonna revolve about this line. So which means that I will have, this is 4. So this means I have another fixed distance from 4 to 6, which is here, which is going to give me the empty region here. This is an empty region. So let me draw it for you here. And I will have another, because if I rotate, so it's like I'm having this graph like this. Okay, let's go. There we go. As you see here, so this is my inner circle, and this will be my outer. Alright, let me try to do this perfectly, at least you can see the idea. This is my outer. Let me take off this and do another one, at least you will see the idea. There we go. There we go. So it's exactly what I will have. So I need to find the volume around here, and my cross section, you see, is perpendicular to the y-axis. That's why we use dy. See, it's perpendicular, whatever is perpendicular to. Like for example, in the previous question, you see this is perpendicular to x-axis, so I'm going to use the x. Here it's perpendicular to y-axis, I'm going to use dy. So it's exactly what's going on here. So the boundary here is going to be from 4 till when x equal 2, so it's going to be 8. So this is the boundary of y. So we can change it to x, so we will see what to do. Alright, so here what do we have? We have the inner circle and we have the outer circle. That means we have the inner disk and the outer disk. And to integrate, what we do the outer disk minus the inner disk. You see? The outer disk minus the inner disk. I'm going to do the outer area minus the inner area will give me the area between them, times dy, then I will get my partial volume. So the partial volume here is going to be, you see, okay, let me talk about the radius of the inner circle. It's 2, because from 4 to 2 is 2. This is 2. Now for the outer, you have to be careful. Look, the outer. Let me choose another color. You see, the outer is from here to here. But look at this. This is my x. X and up here. That means the distance from here to here is x. And the distance from here to here is 4. And my radius is this part. You see, the whole thing is 4. This portion is x. That means I took from 4 x. That means my radius here, which is this one, will be 4 minus x. So the outer radius is 4 minus x. The inner radius is fixed, is 2. So let me repeat this. You see, the distance from here to here is 4. The distance from that point to the x-axis is x, because here x start from, the distance start from 0. From here to here is x. That means whatever left here is my outer radius. So is 4 take out x. 4 minus x. So this will be my outer radius, and my inner radius will be just 2. So I just need to use the formula of the volume of a cylinder. So is the area of the disk times the height. So the disk here, the outer disk has a radius, so it's going to be the outer disk will be 4 minus x squared times pi times dy, because this will be my height is dy, because it's perpendicular to the y-axis. Whatever is perpendicular to is your d. If it's perpendicular to the x-axis, dx. Perpendicular to the y-axis, dy. And the second one, minus, so this is the outer minus the inner. So the inner is fixed, so it's going to be 2 squared times pi times dy. So this will be your partial volume. Now to find out the volume, what I do? I integrate. But here I have a problem. Here it's okay, so I know the boundary here between, let me fix the boundary here, it's between 4 and 8. Because this we find out this is 4 and 8. How we find out 8? I just plug in the 2 here into the function, so it's going to be 4 plus 4, which is going to be 8. So this the limit of my area here. So here is going to be from 4 to 8. So here it's okay, so I don't need to do anything, I just need to integrate and substitute. But here I need to make sure that my variables are the same. So what I need to do here, I need to change it from dy to dx. So here I will have y is x squared plus 4, so dy is 2x dx. But when we change from y to x, I need to change the boundary too. So you should understand this. So here it's going to be from 0 to 2, because this is the boundary here. So here is going to be from 0 to 2. So here I will have my volume will be the integral from 0 to 2, and I will have 4 minus x squared pi times dy, which is 2x dx. And this you can leave it like as this, it's not big deal because we don't need to do nothing here. So again here you need to FOIL and distribute the 2x, and let me pull out the 2 pi outside, so it's going to be 2 pi and between 0 and 2, and here I will have 4, so it's going to be 16 minus 8x plus x squared times x dx, minus, and here is going to be just 4 pi y going from 4 to 8. Here I distribute and integrate, so here is going to be 2 pi 0 to 16x minus 8x squared plus x cubed dx, and here is going to be just 4 pi times 8 minus 4, which is going to be 16 pi. Now let me get some space here, for me to finish my, so this will finish here. So here I will have 2 pi, then I will integrate, so it's going to be 8x squared minus 8x cubed over 3 plus x 4 over 4, and this between 0 and 2. For 0 will be no problem, it can just disappear, and I just need to plug in the 2 here and simplify my, so this is going to be my v, so it's going to be 2 pi, and here will be 32. So here 32, here will be 8 times 8 is 32, so it's going to be 64 over 3, and here will be 16 over 4, which is just 4, minus 16 pi, and so here if I do the calculation, normally I should end up having 40 pi. So if I, so this is going to be 12 over 3. Here's going to be 96 over 3. So 96 minus 64 plus 12 over 3. So here I will have, here it's going to be 32, so it's going to be 44 over 3. So 44 over 3 times 2 pi, so it's going to be 88 over 3 pi. Then you multiply this by 3, so it's going to be 48. So 88 minus 48 is going to be 40. So 40 over 3 will be my answer here. I hope it's clear. So let's do next question. Air is being pumped into a spherical balloon and the volume is increasing at the rate of 100 centimeters cubed per second. How fast is the radius of the balloon when the volume is 10 centimeters? So here they give me the volume already. So the volume is 4/3 pi r cube. So I already know the derivative of the volume, which is 100. So I do here, I take the derivative. So v prime is 4/3 pi 3r squared times r prime. Keep in mind r prime should stay because my variable here is not the radius, is the time. That's mean r is not my variable, the time is my variable. So when I take the derivative, I keep my r prime. I hope it's clear. Now what I do here, this is cancel out, so I know that this is 100. It's going to be 4 pi r squared times r, and we know that r here is 10, so it's already given to me here. It's going to be 10 equal 4 pi times 10 squared, which is 100. So divide the whole thing by this, and you get your r prime, which is going to be 100 over 400 pi. When you simplify, I have to 0, simplify to 0, so it's going to be 1 over 4 pi, and of course here's going to be centimeter by second. So next question. So here a poster is to have an area of 54 inch square, and here with the margin 1 at the bottom and side and 2-inch margin on the top. So what dimension will be the greatest printer area? So here they ask for this area, printed area, so they're looking for the largest printed area. So I know that this is my x, so I assume this is my x. The length, the width is my y. So the printed area, it has what? Y minus 2, you see, and x is going to be x minus 3. So this will be the dimension of my printed area. So what is my area of the printed area is, so the area will be y minus 2 times x minus 3. So this will be my printed area. So let me name it P. In that case you will understand, but it's not perimeter, it's the printed area, PA. Now we're looking for the largest dimension, so we're gonna see what is the largest dimension by using the derivative here. So but the problem here, I have two variables x and y, but I know that x times y is 54, so they are related, so which means that I will have y will be 54 over x. So I substitute my y here, so my printed area will be 54 over x minus 2 times x minus 3. Now what I do, I FOIL and I took my derivative, so x times 54x is just 54. Then I will have minus 2x minus 3 times 54, which is 162 over x plus 6. So this will be my printed area function. Now what I do, I take the derivative, so the printed area derivative, and I make it equal 0 to see the largest dimension. So here I will have 54 we cancel out, so it's going to be 0, so it's going to be minus 2, and here will be plus 162 over x squared, and this is 0. Now what I do, I make this one equal 0, so I got 162 over x squared equal to, so which means that 81 is my x squared. Of course x will be 9. Is that clear? Now if my x is 9, so obviously y will be 6, so y is 6, and if I times those two will give me 54. So this will be my dimension in order for me to get the maximum area, so which means the dimension of the printed area will be 4 by 4 by 6, because 9 minus 3 is 6 and 6 minus 2 is 4. So this will be the dimension of my printed area. Alright, next question. Find the area of the region bounded by the graph y equal to x and y equal 3 minus x squared. So also sketch the region. Alright, so here suppose they don't ask you to sketch the region and you want to know which one is above, which one is below. So keep in mind, if I have two functions y1, y2, what I do is subtract those two functions, y1 minus y2, and check when this positive, when is negative. So this, if this one is positive, this means that y1 is above y2. When this one is negative, that means y2 is above y1. So I hope this one is clear. Let me write this because I was writing it fast. Alright, so when the difference is of y1 minus y2 is positive, that's why we'll have y1 is above y2. And if it's negative, that means y1 is below y2. So this is how you should see it. So what you do, if they don't ask you to graph, take the difference and check when this positive and when this negative. So what I do here, so my y1 here is 2x, y2 is 3 minus x squared. So in order for me to integrate, I need to do the above minus the below. Always when you integrate the function, we do the above function, the integral of the above minus the below, always. This is what we do. So here I need to check which one is above and which one is below and where they intersect. So I take the difference between them, so y1 minus y2, so it's going to be 2x minus 3 plus x squared. So this is the same thing as x minus 3, x plus 3 times x minus 1. So if you factor it, so which means that this, it can be 0 at x equal 1 or x equal minus 3. So in my number line, so what I do, I'm going to put those two and check when it's positive, when it's negative. So here we have minus 3 and this is 1. So we know that if this is positive, the coefficient of a of x squared is positive, outside is positive, and the inside is negative all the time. When you have x squared, check the coefficient. If it's positive, outside is positive, the inside is negative. If it's negative, the outside negative and the inside positive. And this is just come from the graph of the quadratic function. Alright, now you see here, tell me what the difference is positive. That means I will have y1 is above y2. Here y2 is above y1. Here y1 is above y2. So now what they want the region bounded by those two functions. This is the region bounded by two functions, which means I have y2 is above y1. So here my integral is going to be between what and what? Between minus 3 and 1, because this is where the region is bounded. And I will have my y2 function, which is 3 minus x squared, minus y1 functions, which is 2x dx, and I integrate here. So it's going to be 3x minus x cubed over 3 minus x squared between minus 3 and 1. And after that I will show you the graph, and you're going to see that this is exactly what we got. So here when you integrate here, so what we'll have, I will have here is going to be 3 minus 1/3 minus 1 minus 9 plus 9 minus 9. So this and this cancel out. So here I will end up having this is going to be 2 minus 1/3 is 5/3. So it's going to be 5/3 plus 9. So it's going to be 9 and 5/3. So this will be my integral. So let me graph this for you here. At least you will see the idea. So if I want to do the graph, I will do just a little graph here. Alright, so this is y equal to x, so that means it's a line. So let me do the line here. Let's assume this is my 2x. I'm just assuming this is my 2x, and here is 3 minus x squared, which means that I have minus square root of 3 here and minus square root of 3 here and plus square root of 3 here. This is where the boundary x intercept, and we have x equal 3, it's here, so 1 2 3 is here. Alright, as you see here, this is how the graph look like, and this is 1, and here is minus 3. I'm just assuming this is minus 3. So as you see here, this is my y2 and this is my y1, and as you see here, it's positive. y2 is above y1 between minus 3 and 1, which is what we find out here. I hope it's clear. So let's do the next question. So here, suppose the derivative f prime of the function f has the graph. So this is my derivative. Find the open interval where f is increased. See here, they give me the derivative. This is my derivative. So in order for me to check if it's increase or decrease, I don't need to check anything except the sign of the graph, when it's positive, when it's negative. Increase, that means the derivative is positive. I'm going to see where it's positive. That means a positive in the graph, that means above the x-axis. Negative, below the x-axis. Positive mean above the x-axis and negative below. Positive here, that means is above, and this is above. That means in these two location the function is increasing. So that means for the first question, I just need to say the function is increase is increasing on the interval on, we have minus 1 1 and the interval 3 to infinite. So this is where the function is increased. That means where the derivative is above the x-axis. The derivative above the x-axis. The derivative above the x-axis. Now find the open interval where f is concave down. What does mean concave down? The second derivative is negative. You see, the second derivative is the derivative of the first derivative. The second derivative is the derivative of the first derivative. That means concave down. That means when the function is decreased, when the derivative is decreased. So I'm going to see where the derivative is increased. The derivative is decreased here. You see, the derivative is decreasing here. That means the second derivative here is negative. You see, when we talk about second derivative, we're talking about if the derivative is increase or decrease. The second derivative, we need to check if the derivative is increase or decrease. So here the derivative decrease. That means the second derivative is negative. That means the function is concave down. So that means here f is concave down on the interval 0 2. Okay, find the x-coordinate of the relative max and min for f. You see, here is my relative extremum. Here is my relative extremum. Here is my relative extremum. But which one is the max? Which one is the min? You see here, it's negative, positive. That means the function. This is negative. This is positive. That means the function here decrease. Here increase. The function decrease. Then when it comes to that one is increase. As you see here, it's a minimum, relative minimum. Here it's positive. That's become negative. It's positive, that means the function increase, then decrease. That means this is relative maximum. Here is negative and positive. That means the function decrease on that side and increase on that side. As you see here, we have two relative min and one relative max. So don't see it as the location here. I'm just drawing it just to show it to you. So here you see what you have to check. The derivative here is negative. That means the function is decreasing. You decrease. Derivative here is positive, is increase. You see, decrease, increase. Minimum, local minimum. Here the derivative is positive. This is negative. That means derivative positive, increase, decrease. Here negative, positive, decrease, increase. So as you see here, that's exactly what's going on here. So at x equal -1 and x equal 3, we have local min, and x equal 1, we have local max. I hope it's clear here. Alright, next question. So the velocity function in feet per second of particle moving along a line is given by. So here they give me the velocity. This is my velocity. Find the total distance. Here what you need to do, the total distance is the integral of the velocity. Is the antiderivative. So the integral, and the integral is what? Is the area. So what I am going to do here, I'm going to find the area of this shape. So this is the right triangle. I'm going to find out the area of that one, plus that area, and I'm done. This is a trapezoid, and this is a rectangle. So the area of a triangle is what is, so that's mean total distance is going to be what? The area of that one, which is half, the base is 3, times the height, which is 100. Plus, I'm going to do the area of the trapezoid. So the area of trapezoid is the height, so the height here is 1, so it's going to be 1, times base 1, which is 100, plus base 2, which is 400, divided by 2, plus, and here this is a rectangle, so it's going to be 1 times 400, plus 1 times 400. So here I will have 3 times 50, plus 500 over 2, plus 400. So here is going to be 150, plus 250, plus 400. So here is going to be 400 plus 400, which is 800 feet. So I hope it's clear. So let's do the last question. So here we have a time t in second, the coordinate st in feet. A particle moving at the line is given by. So here they give me st at this is t squared minus 8t plus 18. When you have this type, which is quadratic, try to make it as what you call it, like the vertex form. What is the vertex form? The vertex form is look like this, like x plus a plus b. So this is the vertex form. That means this is my coordinate of the vertex. So try to make this in this form. It's very, very, very important. It will make your life easy, and you're going to see it just right now. So here is the same thing as t squared minus 8t. So to make it this in vertex form, so what I do, I add half of this one square and subtract it again. So it's going to be minus 8 over 2 square minus 8 over 2 square plus 18. So I just take this coefficient, divide it by 2, then square it. I add and subtract. So this will give me my perfect square, and this I will simplify it with the 18. So here we'll have t square minus 8t plus 16. So it's going to be plus 16 minus 16 plus 18. So this is the same thing as t minus 4 square plus 2. So it's exactly what is my s of t, is my function. And look how this will help me solve my problem. So here they ask me to find out the average velocity on the interval for 4.1. So what is the average velocity? Average velocity, so is what is s of 4.1 minus s of 4 over 4.1 minus 4. So here, what is s of 4? You see, I just need to plug in here. It's better for me. This, it's much better than this. So here I will have 4.1 minus 4 square plus 2 minus, and we have 4 minus 4 square plus 2, the whole thing over 0.1. So here I will have just 0.1 square plus 2 minus, and here this is going to be 0, so minus 2 over 0.1. This is cancel out, so I simplify this, so it's going to be just 0.1. So that's exactly what is my average velocity, is 0.1. Now calculate the particular average velocity over the time interval 4 and 4 plus delta t. So it's the same thing here. I will have the average velocity here, so it's going to be s of 4 plus delta t minus s of 4 over 4 plus delta t minus 4. So this is cancelled out, so what we'll end up having 4 plus delta t minus 4 square plus 2 minus 4 minus 4 square plus 2. You see, it's straightforward. So here is going to be just delta t. So here the 4 cancel out. This is 0. So what's left is delta t square plus 2 minus 2 over delta t. So this is cancel out. I cancel the 2 here. I simplify delta t square over delta t is just delta t. Oops, sorry. So let me write it down here. At last it's clear. So here it's going to be just delta t square over delta t. It's going to be just delta t. I have a problem here with my Alright, this is about the question B. So for question C, so find the particle instantaneous velocity at t equal 4. So you just need to take the derivative and put 0. So first thing, let me take the derivative of t squared minus 8t plus 18. So st is t squared minus 8t plus 18. So I take my s prime, which is going to be 2t minus 8. Now, what is instantaneous derivative at 4? Just substitute 4 here, so it's going to be 8 minus 8, which is 0, and this will be your answer. So I hope you got the idea how to do this type of question. So I hope my explanation was clear. So please, if you have any comment about the way I present those lesson and those review, do so. It will help me a lot, improve my way of teaching. And thank you very much for watching the video. Assalamu alaikum.